Hey Chemistry, Mrs. KJ here, and I'm going over the Unit 2 lab. And so what I did was just to move everything over to an area. So you can see that I have some chalk here, water, vegetable oil, vinegar, citric acid, and sodium hydroxide. I put a scoop of chalk in each of the outer wells. The reason I chose the outer wells, if you'll notice, when I hover my finger over it, I can click and hold, and then I can see the actual, let me brighten up my screen. There I go. I can see the actual side view of the well plate. And now what I'm going to do is I am going to click once to get some water, and I am going to continue clicking until all the water is gone. And set it down, and we're going to take a look here. All right, so we added the water on top, and now I'm going to stir it and throw that in there and click on it again, and you can see that is mixed up. I'm not sure why it turns brown. White chalk is not going to turn brown in water like that, so this one is just a glitch, but I did at least want to show it to you. So we're going to move on. The next one, we're going to do the same thing with the vegetable oil. And we'll go ahead and set that back down. If it will let me. There we go. And we will mix it up again. If you notice, every time I am taking a clean stir rod and, oh, look at my side view here again, and go ahead and write down some observations. And specifically where you're going to write that down is where it says record observations here before evaporation. So it was chalk. And you can see the water, I said this one has a glitch and should be white. So right here in this box, you're going to fill in the chalk and the veggie oil. Okay, so you're going to write in some observations. So for example, you might write that the yellow liquid is on top and there's a little bit of white powder on the bottom. All right, let's go ahead with the vinegar. And as you can see, they're showing the liquids as a blue. So the blue is the color of the starting liquid. More in there maybe? Nope. And the white was the color of the powder, the chalk. All right, so now I'm going to mix it. And side view. And you definitely notice the difference when we're looking down in, because now it's like you can see through it all. So what happened to that white powder? What happened to the chalk? And that's what you are going to write into vinegar and the chalk. What happened to the chalk? All right, and so now let's do our citric acid. And again, you can see now it's kind of cloudy when I just put it together. And whoa! All right, what do we have going on there? We definitely have some bubbles. And along with bubbles, what else do we have? We had a color change. It is now brown. All right, so turned brown and bubbles. And as you can see, the bubbles are slowing down because the reaction is finishing. It's using up all of the chalk and the vinegar. It's using it all up. And once they're all used up, it's going to stop reacting. So, all right, so we have citric acid. So we're going to bubbles and turned brown. All right, so this one we said it was yellow, liquid, white on bottom, and this one, the chalk dissolved. All right, so if you put something else, make sure you fix it. So with the vinegar, the chalk, when we mixed it up, it just dissolved. Is the chalk still there? Yeah, it is. The chalk is still there. The vinegar is still there. They just became a physical mixture. We can still separate them. However, check out this bubbles and turn brown. Do you think we can get back the citric acid and the chalk? All right. So let's go ahead and let's do the last one here. We have our sodium hydroxide, NaOH. All right, and we'll look at our side view here and check it out. What are you going to write for that one? So there's two things you're going to write down, and I'm not going to write this one down for you. So this one you got to write down. So two things that I'm looking for. And be careful though when you say the color, because we said brown for this one. So you can't choose brown for this one because they're obviously different. You can describe the brown and say that one of them was darker, one of them was lighter, or you can use a different color. As my husband says, there's only 12 crayons in his coloring box, so he would just say light brown. But I know some of you have some more color selection in your repertoire. So go ahead and tell me the color on that one. All right, so the next chemical that we're going to do is NaCl. So I'm taking this metal scupula, and yep, it's called a scupula, and I am putting a scoop of table salt in each of the wells. Now with this lab, I can only use the outside wells because otherwise I can't see a side view, and it's just a lot harder if you can't see the side view. So that's why we're going down on the bottom. And what's the common name for NaCl? It is table salt. The chemical name is sodium chloride. So we're going to add some water to sodium chloride. And we are going to go ahead and stir it right away as well. You see me bouncing up here, I'm locking the screen so that it doesn't move all over on me. And we're going to go ahead and take our side view. Now you'll notice the white chunks, but before you say bubbles, were they going up or were they going down? They were going down, right? So they weren't bubbles, they were just the pieces of salt falling to the bottom. That's all it was. Okay, so the pieces of salt fell to the bottom. So that's what we're going to go ahead and write here. So pieces of salt fell to the bottom. All right, so I wanted to make sure I showed you that one because that one, for some reason, people have bubbles on their mind and then they think bubbles and it's like, no, they weren't bubbles, down, not up. All right, so next we are going to do the vegetable oil. And if you're thinking, I kind of thought the salt was going to dissolve in the water. Salt does dissolve in water, but in this case, there was not enough water to dissolve the salt. All right, so this one looks pretty yellow. Depending on, you might have to kind of tilt your screen back and forth or move your eyes. And this one I can see kind of little tiny dots, but I think that's just the salt and the oil. So this one's just salt mixed with oil. All right, so we have the vinegar next. All right, and we'll go ahead and mix that up. And we'll look at our side view here. And the salt looks gone, which is different than here, right? Because here you can definitely see the salt sitting at the bottom. There was not enough water to dissolve it. So you can definitely see a layer of salt, even the specks you can see from the top view. But here, you would have to say the salt did what? All right, let's add our citric acid. So again, I'm expecting that you're hitting pause and filling this out. If you haven't been doing that, go back. Hit pause, fill it out. All right, so this one is the citric acid. And, oh, there we go. We can see it falling down. So make sure you write that down on your observation. And then lastly with the salt, we're going to do the sodium hydroxide. All right, and we're going to go ahead and mix it up. And we'll look at our side view here, and you might have been able to guess once you saw those little white flecks that, yep, you know what to write down for your observation for that one. And again, that one was the sodium hydroxide, or the NaOH. So Na is sodium. OH put together like that is called hydroxide. All right, so I'm not throwing this away. What I'm going to do is set it farther down the bench because I need to save this. I'm going to actually save the whole system, save the whole system, and then it's going to give it time to evaporate. All right, so that was our first one, and so that was, we had chalk up on top because we're going to need to remember that. Labeling is crazy important with labs. And we'll put the salt down here. All right, and then I'm going to grab another set of well plates. And we'll get that salt out of the way. And next on our list is KCl. What does the K stand for? Go ahead and look it up if you don't know. Potassium. And it's Cl. So KCl. And what does Cl stand for? Stands for chlorine. And so together we call that chemical sodium, potassium. Potassium, not potassium chlorine, but potassium chloride. So potassium chloride. And we're going to talk more about how to properly name chemicals later this year. But I figured since we had some here, it was a good opportunity to start having you hear how they're properly said. So potassium chloride. All right, and we're going to add some water to the potassium chloride. And we will go ahead, oh, don't do that. Let me set it down. There you go. All right. And go ahead and make your observations for water with potassium chloride. And I'll go ahead and do the vegetable oil next. All right, and take your side view. All right, and then I'll go ahead and add the vinegar. And we'll go ahead and mix it up. And here's your side view. And go ahead and make your observations for that one. And now we have citric acid. Look back at your observations. What did citric acid do last time? All right, sodium chloride. What do you think it's going to do with potassium chloride? All right, well, we got to mix it first. Ah, maybe not what you expected. Maybe what you expected. Okay, all right, and now let's go ahead and try the sodium hydroxide. All right, and then I just put in the sodium hydroxide into, and there's our side view. And I know time's going to run out, and we will continue on the next video. So go ahead and write this down in your observations.